"I knew I named the company right," said Nvidia's CEO Jensen Huang when Mukesh Ambani pointed out that there's a Vidya in Nvidia, a reference to the goddess of knowledge in Hindi. Welcoming Huang to Mumbai, Ambani explained how, in their tradition, knowledge leads to prosperity. Just as Nvidia, under Huang's leadership, is driving a global knowledge revolution, transforming lives and bringing prosperity worldwide. Let's see Huang's reaction to this. Seems a little too happy, but honestly, I'd have the same reaction if I were him. But what brought Jensen to India? In case you didn't know, the AI Summit India took place last month, where Jensen Huang declared that our industry is experiencing seismic change and tectonic shifts. He then announced something that will revolutionize the tech industry, something we haven't seen in over 60 years. Intrigued? Stick around, and we'll reveal what Huang said about the future of AI in 2025. The 1964 computing revolution. Think back to 1964. Need a refresher? That's the year IBM introduced general-purpose computing to the world with the IBM System 360. This system changed the game for IT, making software compatible across generations of hardware and turning software investments into long-term assets. This marked the start of breakthrough advancements in CPUs, multitasking, and operating systems. But that wasn't the only major shift. The 1960s to the 2010s saw an explosive evolution in personal computing, making it more affordable, accessible, and essential for every industry. The driving force? Moore's Law, also first observed back in 1964, which predicted that computing power would double every 2 years, a pattern that fueled exponential growth. The end of Moore's Law. Now, in a twist of history, 2024 brings us two fundamental shifts once again. What are these shifts, and why do they matter? In the words of Huang, the free ride of Moore's Law has ended, as CPUs can no longer be scaled any further. Could this possibly signal the end of traditional CPUs as we know them? If so, what comes next? Who will take over the reins of computing? That's where Nvidia comes in. The rise of GPUs. Back in 2006, Nvidia launched CUDA, which not only accelerated development in the IT industry, but also enabled the performance of tasks that traditional general-purpose computing couldn't handle. For those wondering, a GPU, or graphics processing unit, is a specialized processor originally designed to handle graphics and images. Unlike a CPU, which handles tasks one at a time, a GPU can process thousands of tasks simultaneously. So a GPU is like a multi-lane expressway compared to a CPU's single-lane road. You know, like that feeling of switching from a congested local street to a smooth expressway. Except here, instead of honking cars, you've got data packets zooming through at lightning speed. This makes it much faster at handling tasks that require heavy calculations, like rendering images or running complex simulations. Nvidia then merged CUDA with its GPUs, creating the first accelerated computing architecture running CUDA. Today, GPUs run at speeds 100 times faster than CPUs. Nvidia has since applied CUDA across industries, dramatically accelerating performance. And I'm not gonna lie, when Jensen mentioned the end of Moore's Law, it hit me that this is the start of a whole new era. But I've seen the leap in performance GPUs bring, especially in AI tasks that involve a lot of computations. Thinking about the future makes me really excited. Now, Nvidia's commitment to deep learning is not secret, but how did it all really begin? About a decade ago, AlexNet, a major breakthrough in computer vision, highlighted the potential of deep learning. Nvidia immediately recognized its significance. This recognition led the company to shift its entire focus toward advancing deep learning and reinventing computing altogether. Over the past 12 years, we've seen this unwavering commitment come to life. You might have already guessed where we are going with this. Along with the shift in computing, there's been another major change: the way we approach software. From software 1.0 to software 2.0. Remember the days when programmers had to write long algorithms every time they needed something done? Huang called this software 1.0, where algorithms would take input, apply the programmer's logic, and give an output. Now, instead of humans doing all the thinking, machines are taking over that task as what we now call machine learning, or software 2.0 in Huang's words. Here, machines observe data and their results, learn from repetitive patterns, and generate outcomes on their own. This shift has transformed how software is developed and applied. So not only are we witnessing the industry move from CPU-based computing to GPU-powered neural networks, but we're also shifting from traditional coding to machine learning, and from software development to AI creation. Nvidia's Blackwell. Now, if you have seen some of Jensen's previous addresses, you might be wondering, did he bring out something mind-blowing this time? Well, he sure did. And this technology will take everything to a whole new level. Remember back in 2018 when Nvidia solved the bandwidth constraints between CPUs and GPUs by introducing NVLink. With an insane 300 gigabyte per second bandwidth, NVLink was a game changer. You can think of NVLink as a superhighway connecting computers, allowing data to travel faster and more efficiently between them. And now Nvidia has taken it to a whole new level. This same NVLink now connects 72 dual GPU packages, a total of 144 GPUs, all working together as one giant GPU. It's kind of like linking together 144 brains, each with a 200 IQ, into a single brain. I'm sure you can imagine now how smart that brain would be. And that's not all. These GPUs are then interconnected by a high-speed quantum switch that runs through the rack's back spine, allowing them to operate together as one unified system for large-scale AI tasks. This is Blackwell, and what you just saw was a glimpse of the architecture of this monster machine that Huang showed at the summit. Huang went on to explain that Blackwell isn't just about raw power. It is a system designed for studying data at an enormous scale. It's designed to detect patterns and learn the meaning of the data across types, from language to images, chemicals to proteins, and so on. It is safe to say that with Blackwell, Nvidia has created a kind of universal translator for data. It can transform text into images, identify objects in photos, generate captions, and even help in drug discovery by analyzing proteins and amino acids. Seeing Blackwell took me back to the first time I watched a sci-fi movie as a kid, dreaming of technology that could do it all. It kind of feels like now those childhood fantasies are coming to life. But here's the kicker. This powerhouse system sold out the same month it launched, for an entire year. So if you happen to own a big tech company hoping to get your hands on one, I hate to break it to you, but you'll be waiting at least 12 months before you even get a chance. Scaling AI models. Now, something as powerful as Blackwell requires a model that matches its capabilities. As data continues to grow rapidly each year on its own, Huang pointed out that the scaling law in AI model training has enabled a rapid increase in model size as well, allowing them to handle vast amounts of data. This scaling law has outpaced Moore's law, with both data and model sizes doubling annually, leading to a fourfold increase in computational power. This surge in power is what enables models to process a wider variety of data types, such as text, images, and even audio under a unified framework. Furthermore, he highlighted that today's models aren't just getting larger, they are also becoming much more sophisticated. With new techniques like reinforcement learning, AI can now learn from real-world results and feedback, not just from pre-existing static data. Additionally, synthetic data generation, where computers create extra training data, helps make models even better by providing them with more varied information to learn from. These advancements have allowed models to grow significantly by 20, 30, or even 40 times their original size, which in turn raises the demand for computing power and pushes the boundaries of what AI can achieve. But Nvidia's CEO didn't just stick to tech talk to prove his point at the summit. If you've ever wondered what his favorite Indian food is, you don't have to wonder anymore. He straight up told us it's chicken biryani. And he didn't even have to think twice about it. Kind of like how ChatGPT can serve up a fact without missing a beat. But here's the thing. If all we needed were just facts, what's the point of having ChatGPT? Wouldn't it be the same as using Google? This is where the difference comes in. What sets ChatGPT apart from Google is its intelligence. And it is none other than the scaling law that has allowed models like ChatGPT to interact with us in ways that feel human. Now that we've mentioned ChatGPT, let's talk about how we have now reached a point where Nvidia isn't the only player in the AI hardware game. Hopper, Nvidia's GPU architecture built to speed up and optimize AI model training, made a major impact when it launched, prompting other companies to jump into developing their own foundation models. As Jensen pointed out, the number of companies working on these models has more than doubled since Hopper's release in 2022. This surge has led to powerful AI systems like GPT-4 and DALL-E. With these advancements, the need for data and computational power has skyrocketed. And it's not just about training, there's also inference, which is the process of using a trained model to generate outputs based on new data in real time. For tasks like natural language processing, where the model is producing words or tokens at high speeds, inference can demand just as much computational power as training. No wonder the Blackwell has already gotten sold out. AI in India. But since this was AI Summit India, let's get to the headline that Jensen told when discussing how this technology is being applied and used to advance innovation across the country. Nvidia is AI in India. He emphasized that the first step in building a robust AI ecosystem is developing the necessary AI infrastructure. To this end, Jensen proudly announced that Nvidia's partner companies are collaborating with them to establish a fundamental computing infrastructure in India, which is expected to increase computational power by a remarkable 20 times compared to the previous year. 20 times. Let's pause on Huang's announcement for a moment and explore Mukesh Ambani's perspective when Jensen asked him about making India not just a hub for IT, but a global center for AI. Ambani highlighted India's unique advantage, its ambitious and talented youth. With an average age under 35, India's younger generation is brimming with raw talent and a strong sense of aspiration, making it a prime contender for becoming a future AI powerhouse. However, talent alone isn't enough. It needs proper guidance and infrastructure. In this regard, Ambani emphasized how the current leadership under Prime Minister Narendra Modi has been pivotal in transforming India into a digital society, building an ecosystem backed by world-class connectivity infrastructure. Ambani also pointed out a major milestone, Reliance Jio's role in moving India's internet ranking from 8th to 1st globally in just 8 years. He highlighted Jio's affordability, delivering data at just 15 cents per gigabyte, a stark contrast to the US average of $5 per gigabyte and the global average of 3.5. With Jio's price, even your grandma might be tempted to start a data plan. This affordability has made technology accessible to all, helping India transform from a manufacturing base into a global innovation hub, where international companies can drive advanced research and development. At this pace, India's 20x scalability in computational power doesn't seem far-fetched. LLMs in India, the hardest language model region. Now let's get back to Huang's address, in which he also highlighted the importance of large language models, LLMs, referring to them as the operating systems of AI. Nvidia has partnered with several organizations to create Hindi LLMs, tailored to cater to the diverse linguistic landscape of India, which includes 25 officially recognized languages. If you have ever been to India or interacted with Indian people, you would know how diverse and dynamic the country's language scene is. So creating Hindi LLMs is no simple task, given how their linguistic landscape is incredibly complex, with a wide range of dialects and languages spoken across the country. Jensen went as far as to say that in India, you can find a new dialect every 1,500 kilometers, making it the hardest language model region in the world. But later in the summit, Jensen invited Vishal Dupar, the managing director of Nvidia India, to join him on stage. Vishal, being an Indian himself, added his own perspective, saying that it is not 1,500 kilometers. In fact, you can encounter a new dialect every 50 kilometers, further emphasizing how challenging this task can be. Nvidia's servers are probably struggling with the nuances of chai, wondering if it means tea, gossip, or existential therapy. And let's not even start on the debate between Pani Puri and Golgappa. AI might need its own translator soon. In terms of AI application development, Jensen also highlighted India's growing role in the application layer of the AI ecosystem. Currently, there are many AI native companies in India creating innovative applications that are already changing industries. These companies are developing AI-powered solutions in areas like healthcare, education, and agriculture, which are making a real difference in people's lives. On top of that, Nvidia has formed partnerships with major service providers like Wipro, Infosys, and TCS. These companies are helping to deploy Nvidia's AI models and infrastructure, enabling global enterprises to scale their AI capabilities and solve complex problems. This collaboration is crucial for bringing cutting-edge AI to industries far beyond tech, whether it's improving efficiency in supply chains, enhancing customer experiences, or even tackling climate change. What's happening in India is not just about advancing technology. It is about empowering businesses and people to harness AI for solving some of the world's biggest challenges. Towards the end of the summit, Jensen talked about the Nvidia AI Enterprise, a platform that has paved the way for AI systems that don't just understand data, but can also respond to it effectively. Huang referred to these AI systems as agents and explained that what makes these agents so powerful is their combination of perception and reasoning. Perception allows these agents to interpret data accurately, while reasoning enables them to break down tasks into manageable steps. This step-by-step process allows them to respond to data in an organized and precise way. It is this capability that makes these AI agents more than just tools. They act as super employees, enhancing productivity and scaling up the efficiency of entire teams across various industries. But as Huang pointed out, training these agents is crucial. They need to go through a comprehensive training process to ensure they understand their tasks and the boundaries they should not cross. And Nvidia has a solution for this. The entire process, from building and customizing to deployment, is managed by Nvidia's NeMo framework. This powerful tool simplifies the creation and integration of AI agents, enabling industries to harness these technologies at scale without the complexity. Jensen's address at the summit made it clear that while technology is advancing rapidly, the journey is just beginning, and the possibilities are endless. Personally, I'm always amazed by the continuous improvements in machine learning and can't wait to see how Software 2.0 will evolve. But what about you? What excites you most about AI's future? Share your thoughts in the comments. I'd love to hear your predictions. And hey, if you're curious about how AI is going to change in 2025, check out our video on ex-Google CEO Eric Schmidt reveals dark AI future we can't ignore. Thanks for watching, and I'll see you in the next one.